All right, problem 45, back to our coordinate plane. First, we're going to plot the points. I'm going to plot them and make sure that I label all of them. So at A, we've got -1, 2. That's A. B, we've got 0, 1. That's B. And C, I've got 1, 2, 1, 2, 3. That's C. So we need to do several things here. We first need to show that the triangle is a right triangle. And the only way to show that something is a right triangle is to show that it has a 90-degree angle. Which basically means that two sides must be perpendicular. Now, we know whether or not sides are perpendicular based on their slopes. So I'm going to need to find, using the slope formula, the slope of two of the sides. The slope formula is usually the squiggly m equals y2 minus y1 over x2 minus x1. And looking at my diagram, I have an idea of which sides I think are perpendicular. I think that AB and BC are perpendicular. So I'm going to go ahead and try to show that AB and BC have negative reciprocal slopes because that would make them perpendicular. So I'm going to start off down here, find the slope of AB and find the slope of BC, and hopefully those will be negative reciprocal slopes. So AB, I'm going to do y2, which is 1, minus 2, over x2, which is 0, minus x1, so 0 minus -1. 1 minus 2 is -1. 0 minus -1 is 0 plus 1, or positive 1. So I'm going to leave my slope like this for now. BC, let's do the slope of that. From B to C, I've got 3 minus 1 over 2 minus 0. 3 minus 1 is 2. 2 minus 0 is 2, which is the same thing as 1 over 1. 1 over 1 and 1 over -1, or -1 over 1, these are negative reciprocal slopes. So AB is perpendicular to BC. Therefore, triangle ABC is right. All right, step 1 done. Step 2, how about dilation? Dilation meaning to make it bigger. Same exact shape, but bigger. And they want us to perform a dilation with a scale factor of 2 on each of the vertices of this triangle. Basically, that means I'm just going to multiply the vertices by 2. So in a new color down here, I'm going to look at A, which was -1, 2, B was 0, 1, and C is 2, 3. They're going to become new coordinates by this dilation. A prime, B prime, and C prime. And these will just be multiplied by the factor of 2. And when we do that, we do it to both points. So if I multiply -1 times 2, it's -2. 2 times 2 is 4. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. So using this, we have stated the coordinates and we need to draw the dilation image. So I'm actually going to go back. So I'm going to say -2, 1, 2, 1, 2, 3, 4. That's where A will end up. B, A prime. B prime will be at 0, 2, 0, 1, 2. And C prime is at 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. C prime. So as you can see, it looks exactly the same shape, but just a little bigger, specifically twice as large. What is the ratio of the area of the dilation image to the pre-image? So basically here, the pre-image is what we started with, the first triangle. That's ABC, and the image is A prime, B prime, C prime. And they want the ratio of the areas of the image to the pre-image. Now, like we talked about before, the ratio of the sides, let's pick a different color here. The ratio of the sides is going to be basically 2 to 1, because our new image is twice as long as our first image because we multiplied everything by 2. So if we want to get the ratio of the areas, all we have to do is take our sides and square them. So that's going to be 2 squared to 1 squared, or basically just 4 to 1.